So I would like to give the floor to our distinguished speakers today. And the first one will be Professor Amit Sheth from University of South Carolina. He's an educator, researcher, and also entrepreneur. He is also the NCR chair and a professor of computer science, and also he founded the university-wide AI Institute at the University of South Carolina. So happy to have you, Professor Sheth, today as a speaker, and I give you the floor. So we'll have for questions later, so you can use the chat to ask your questions, and happy to give the floor to Professor Sheth.
Great. Let me see if I can. Well, it is. I'm very delighted to be part of this activity. Thank you everyone for joining, and thank you for inviting me. I've been given the task of talking about probably one of the most important component of the next generation of AI systems, reasoning and abstraction. These are very key components of building the intelligence in the AI system, along with the two other important characteristics, robustness and trustworthiness. Um, I have been an entrepreneur, founded three and co-founded fourth company, three of them by licensing my own university research, and three of them are in AI. So it's good that here there is an objective to support entrepreneurs here. At the AI Institute, we have a very strong foundational AI agenda, and here, for this talk, it kind of belongs to this intelligent, robust, and trustworthy AI theme, along with use of neurosymbolic AI approaches. And you can see that we work, we have collaborations with many different areas. One of the distinguished feature of our work is that practically all our work has real world problems, real world data, collaborations from those domains, and then we do AI research, prototyping, and very often they result in evaluations with real world, again, benchmarks, and often it results in tools, technologies that are deployed, and sometimes we spun off companies. I just put out a report. The title is C-Cube AN, Custom Compact Composite AI Systems. And the thing that we talk about in this report is what is, how the AI will evolve. I see the theme here about, next generation of AI. And this is my take in that Gartner recently noted that within 3 years, 50% of the AI systems will be enterprise AI system involving technology that is not primarily based on large language models, which is all the rage now. So while for content and issues and for creativity, LLMs and VLMs work very well. For enterprise applications, you're going to need, what I have characterized as the intelligent, robust, and trustworthy AI. And you can see here on the left hand side, there are 14 important foundational elements. I'm asked to talk about two of them today, the reasoning and the analogy. We have papers and articles on all of the on most of these, more than 10 of these. So if you are interested in our views on how each of these elements can be supported, they are available for you to pursue. Now, a core to our approach is this neurosymbolic AI, and I'm going to do a very fast introduction on that. Basically, this involves combining the neural networks and deep learning on one side, and the knowledge graph and knowledge representation on the other side. And by connecting these two, you get a system that supports those 14 elements much better. Um, this is something at least my team started working long time ago. In fact, my second commercial company had combined both statistical machine learning classifiers and knowledge graph for semantic search. That was in year 2000, and we have been doing this work in this area for quite some time. Daniel Kahneman has popularized this concept of system one or thinking fast and system two, thinking slow. Before I came to know about his ideas, which have been very influential, I had also written about semantic, cognitive, and perceptual computing. You'll find a lot more about this general theme in the class series of papers on that topic. But what I want to basically say is that um, our brain support pursues both of these perceptual and cognitive aspects of learning and intelligence, and in the process utilizes broad variety of knowledge. And Right now, as you are listening to me, you are using your understanding of grammar and lexical knowledge. You are using your linguistic knowledge, you are using your common sense knowledge, you're using a broad and general purpose knowledge and or world model, and you're using domain specific knowledge. All of these are being used. Imagine how would you expect a data driven generative AI system to support intelligence and to support certain features if you are not using all this knowledge, because that current system is heavily reliant on large data, but they don't utilize knowledge very well. But there are increasing number of uh, 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 examples where use of knowledge is shown to be um, very valuable in improving the results. For the lack of time, I am not going to discuss them in detail. Now, coming to the first topic of reasoning, there have been classically number of forms of reasoning that have been discussed: deductive, inductive, abductive. I assume that most of you are well aware of these things. Reasoning is just so fundamental to problem solving, decision making, and scientific inquiry. So, uh, how do you support all of these in your system, in your AI system? Now, evolution of the AI reasoning, has involved classical AI-based, logic-based reasoning. It has involved semantic AI, knowledge-driven reasoning, and currently there is a statistical and pattern-based reasoning. There is reasoning model like R1 and O1, and what because the word reasoning is used with along with these variants of the LLMs, they seem to imply that they can do a lot, but in my view, they do very small fraction of reasoning that will be necessary, especially for decision making in enterprises. So LLMs have a whole bunch of limitations in what they call as reasoning, but the chain of thoughts is coming out as a very interesting option. And yet, if you think about chain of thoughts, really, a long chain of thoughts would involve very substantial human involvement in guiding their process. So it's not something that LLM is all that intelligent per se. Um, and there's of course reinformation RL, and that also has that works very well for certain applications, let's say chess or Go, but not necessarily for many other applications. So in the real world, the reasoning requires external knowledge, heuristics, and structured rules that are not part of current framework of LLM reasoning. And there are a number of things that LLM fail in the real world reasoning. They perform well on benchmarks, but if you go to real world reasoning, given the uncertainty and complex knowledge involved, they don't do that well. Um, so I'll give an example, but basically, there are a whole bunch of requirements reasoning. This is a slide, rather old slide. On the right hand side, I'm showing an ontology. and we have Barry Smith, who is an expert in ontology development. Um, in this context, we had the need to find semantic association between somebody who's trying to open a bank account and all the various lists like Bank of England sanction list and federal sanction list and so on and so forth, and trying to find meaningful complex relationship is very challenging. I'm showing you here a relatively complex relationship that involves connecting entities through meaningful specific relationship types. So it's not arbitrarily relationship purely based on probabilities and set, based on the patterns. It is something that you are only interested in specific relationship. So here, after having found the relationship, you are doing scoring. So there is a combination of both, um, uh, the classical reasoning as well as statistical, information that would be necessary for supporting this kind of real world complex relationships and reasoning. Currently, we are working on a very exciting project on school behavioral health and mental health. And basically, here the reasoning would involve a series of steps where John has a anger issue. John is a student, and that there will be a series of things. School counselor says John will be part of Mr. A's anger management class, but then there is a protocol or rule or regulation saying, well, if John is less than 17, there should be an MD, a doctor present, and that we don't. Then school says, but we don't have budget for that, and then district comes back and say we have budget for that. So this reasoning can be fairly complex, involving abductive and deductive reasoning, and it requires grounding in domain process knowledge. Here is another example where it gives you insight of what is involved in reasoning. For example, you see a text here, really struggling with my bisexuality and such. This is a Reddit text, and we are trying to understand whether this is indicative of OCD, obsessive compulsive disorder. And there is a specific definition of OCD with specific required concepts in that. Now, when you see, so what happens is that you are going to have to understand whether in this text you have grounding for some of those concepts necessary in classifying this as OCD. And so here we use knowledge graph, and what is important is that you may map a term to a concept in a knowledge graph, and then you may use taxonomic information to get a higher level of representation, which may be mentioned in your definition. So you may use taxonomic knowledge representation as part of this whole reasoning process. So you can see that the reasoning that will allow you to explain that this is an example of OCD, or this person exhibits OCD, is fairly complex, and without purely based on statistical approach, it would have been very, very hard and low quality. Moving to the second topic I was asked to address is abstraction. And I here start with a real, a person who has really made foundational contribution to this area, Douglas Hofstadter, the guy who wrote the Gödel, Escher, Bach book, very, very well-known book. So he said, analogies are core of cognition and abstraction are the representations that fuel analogical reasoning. This is how we learn new concepts and make sense of new situations. Now, what is interesting is that today's, so here you are using a solar system as an analogy of atoms. And then the top figure shows that there is a whole ladder of abstractions that you go from the thing in itself, how do we see it, name of that thing, it's a cow, it's a part of, is a type of livestock, farm asset and wealth. all these kind of levels of abstractions are necessary to have this human level of intelligence and to do analogies effectively. So, if you want to have verbal analogies like oxygen is to gas as aluminum is to metal, now what happens here is that uh, there are some kinds of these things that language models do fairly good at because there is enough data available. But what happens is that analogy is relatively complex subject. So you have a simple lexical analogies, um, then you have syntactic analogies. A cat meowed at me and dog barked at my brother. Then you have semantic ontologies. She has a heart of gold. And then you have pragmatic ontologies. As you go up these levels of abstraction for analogies and more complex analogies as you go up, the current strategies, current AI models rather fail. Here I have given a concrete example where in a school curriculum we are using quilting as a way to understand carbon cycle in the course on earth sciences. So earth and climate science, that you have concept of carbon cycle, and you can see this is not a simple thing. There are multiple concepts involved: carbon, poly synthesis, sugar, animal eat, all that kind of stuff. And the representation of this whole concept of carbon cycle has a variety of concepts that are stratified. You have entity level animals, but then you have more complex subgraph with individual components where carbon and sugar are connected. Finding the analogies here involves structured representation. So in our case, we advocate a neurosymbolic approach for identifying such abstractions informed not only by data and co-occurrence, which LLMs can do well, but also relevant knowledge typically represented in knowledge graphs. So this is so going towards this kind of analogy and support high level of abstraction requires you to really uh, have this neo-symbolic approach that I've been advocating. Here you see that earlier I've shown you this whole variety of knowledge, and here you see, for example, a text. What you need to do, this happens to be a text in drug abuse area, and we developed a very comprehensive ontology called drug abuse ontology, and you are trying to understand entities, relationship, sentiment, interval at which the drug is administered, dosage, route of administration like snorting or injecting. So there are a lot of concepts and types of concepts to be understood here, and in this particular project and approach, we use variety of knowledge to understand variety of complex concepts, and then understand the abstractions that led to more intelligence in our system. I kind of rushed through much of what I had to cover in and my immediate team as well as the AI Institute team, you can see there. Um, okay, so a number of funding and I'm open to question. I think I have left enough time.
Great. Thank you very much for this very nice presentation and also covering this topic. So what you had in mind from the beginning is to discuss the capabilities of AI systems. So the limitations of the current, like most known LLM systems, and then those capabilities to improve the AI systems with reasoning and abstraction and such kind of more intelligence features, let's say that. So the chat is open for asking questions, but waiting this question, I will start with my question regarding, this hype with, most of generative AI providers. They claim that they are covering those capabilities of reasoning, of abstraction, and so on. So when you take now the DeepSeek or the DeepThink of DeepSeek, so Can you comment on that and what is still missed there, comparing what you are expecting from those capabilities?
Yeah, I actually had a slide on LLM limitations for reasoning, and the same general thing also applies on analogies and abstraction. And we do have papers specifically in showing this advanced reasoning or abstraction, and compare them for how much of the thing can be done by LLMs. Of course, LLMs are evolving very fast, right? So we had papers last year, but then since then these so-called reasoning models have come in. But broadly speaking, uh, as I was trying to explain with real world examples of this behavioral health or finding relations, complex relationship related to security applications, these kind of things where you have specific name relationships that you need to understand, this cannot be done by LLMs very well. You have to have, now LLMs have been showing some fantastic results. Unfortunately, we find out that in many cases LLMs have seen that data. There was one very interesting paper that came out, that came out where LLMs were shown to be doing very well at some mathematical reasoning task, and then they simply changed the variable names, and that same system worked very fairly poorly, right? So what it is that there is essentially, these are keyword and syntax based things, right? So when you are creating a vector space and then use the multi-dimensional vector space as your parameter space, you only captured how the tokens and the words in the data fed in the pre-training are related, and the statistics related to the in probabilities that these two words are together. You don't know why they are together. So the fact that these concepts are related to each other, even if you can find complex concepts through in LLM, which is itself a hard thing. You can find words and other things very well. Complex concept is still little words, but some of them it can be done. But why those concepts are related to each other, in what context they are related to each other, you can the
Mhm,
systems don't understand. So I have another long keynote I've given at several places on what these statistical AI systems do is to do NLP, natural language processing. It can do with a very large corpus, it can do translation exceptionally well, but they can't do natural language understanding. Big difference between natural language processing and natural language understanding. And so understanding requires those entities, those relationships in particular,
mhm.
understanding the complex concepts, and they are represented not as some you look at the example of analogy at the base level, word level analogies or sentence level analogies, they can do very well because for surface structures and the word occurrences can really help find those. The moment you
Uh,
go up with these complex analogies and complex representations, which is what is in the real world.
mhm. So if I
Carbon
were to
cycles is
understand,
the
like,
real world. You can't do that. So there they fail.
So if I were to understand your hypothesis, so the neurosymbolic AI is one of the ways to resolve this and to scale on these capabilities, right?
Yes, explicitly engaging the knowledge. So you either infuse the knowledge. I talked about shallow, semi-deep, and deep infusions. There are multiple ways you can you can take knowledge to improve the attention mechanism, or there are other things you can incorporate knowledge at different layers in the neural network. Dealing with, because it has been shown that different layers of the network handle
Mhm.
information roughly at different level of abstraction, and then you can also do externally using RAG. You also, of course, incorporate knowledge. You can take knowledge graph and use it for fine tuning. So there are
So
multiple
what you
ways.
are, if I can summarize, so you are suggesting to move from data-driven AI to knowledge-driven AI.
Yes,
We can
data-driven
conclude
AI
on that.
to, yes, to one that where knowledge, explicit knowledge and knowledge structures are a very important part of them. Whether you include them in the statistical space, parameter space, or you elicit the information from models, language models, and do the reasoning outside. Um, eh, uh, you know,
That's
there are multiple ways that you can combine.
That's great. Thank you very much again for your presentation and